Well, hello 2D, and welcome to another lesson on similar triangles. In this lesson, we're going to be talking how to recognize if triangles are similar, and then go through the process of actually proving they're similar so that you can use that similarity to solve for sides in that triangle. So we're going to start, let's just get this right. We're going to start with this one here. So before you can use the fact that two triangles are similar, you must give reason for them being similar. This is called proving they're similar. Basically, all you need to do, and this is really all you need to do, is list what angles are the same and give the reason why. So there's a set format to doing this, which is what we're going to go through now. Oops, there we go. And so for this particular triangle, we want to prove that triangle QRS is similar to triangle TUS. So when we start that, here's how we're going to write it out. The first thing we're going to do is write out RTP. RTP stands for required to prove. And we're just going to write what they want us to prove. So in this case, we want to prove that triangle QRS is similar to triangle TUS. And then we're going to say given. So you have to take a look at your triangles and see if there's anything that they've given you. And in this particular triangle, they've given us the fact that we've got two parallel lines here. And if we want to use the fact that those lines are parallel, we probably would like to name them as parallel in our given. So RQ is a line segment that is parallel to TU. And then we're going to start the proof. And all proofs start by restating the triangles you're looking at. So you're going to say in triangle QRS and triangle TUS, we're going to name the equal angles. Let's start with the obvious one here. Angle S and angle S are going to be the same thing. So angle S is equal to angle S. And what is the reason for that? Well, they're opposite angles. We've got two lines that cross, and we know that when two lines intersect, that the angles directly across from each other, called opposite angles, are the same. So we're just going to say opposite angle theorem and abbreviate that to OAT. Now, since we have the parallel lines, we also have the Z pattern going on, which means that this angle here, if we follow the Z, is going to be the same as this angle down here. So we can say TUS. Well, let's actually just use the one thing. If we're going to label it with three letters, we would see TUS, but we're just going to label it with the U. Angle U is equal to angle R. And the reason for that is because of the parallel lines theorem, so PLT, and then it was the Z pattern we used. So we're going to put the Z. Now the last one is also equal because of the Z pattern. You can see we've got a backward Z going on here. So we can say angle angle T is equal to angle Q. And you'll notice I paused for a second there to see which one I was going to write first, the T or the Q. This side of the equal sign came from the same triangle, the SUT triangle or TUS triangle, and this side came from the other triangle. So I want to make sure that I keep those sides the same when I line them up. Now, that's because of the parallel line theorem Z pattern, but I'm going to make it even easier on you. If you have two angles that are already the same, that makes the third one automatically the same because they all have to add up to the same number. They're all going to equal 180 degrees anyway. So you can say angle sum of a triangle theorem. Now, when you're done naming the equal angles, then you're going to just say, therefore, I've proven what I was required to do. So therefore, triangle QRS is similar to triangle TUS, and the reason for that is because all three angles, angle, 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 were the same. So because of angle, angle, angle similarity. And that's all there is to it. You just have to make sure that you can pick out which angles are equal to each other and just write them down in this formalized way. So let's carry on. Here's another one. Example 2. A surveyor lays out two triangles as shown in order to find the width of the river. So the first thing we want to do is show that the two triangles are similar. So they've got letters on them. If they didn't have letters on them, we would have to put those there so we could refer to the triangles. So what are we required to prove for part A? Required to prove that triangle, let's go DEC, DEC is similar to, now we want to make sure we get these letters in the right order on here. And that means that I have to, before I start writing out my proof, I have to determine which angles are going to be equal. So I started with D, which is the right angle, which means that for my next triangle, the order that I'm going to label it in means that I have to start with B, which is the right angle in this triangle. And then I went D, E, C. Well, this E here, this and this makes a Z pattern. So those two are going to be the same. So the next one is going to have to be A. And C are equal because they're opposite angles. So C and C are going to be the next one. So just a quick look at it to make sure that you know which are the equal angles. And you can even mark those down. It might be easier. We know C and C is going to be the same because they are opposite angles. And we know this one and this one are going to be the same because of the Z pattern or because it's the last angle in the triangle. And that would be even easier to say because in order to, we weren't told that BA and DE were parallel to each other. And since we weren't told that, we would have to do sort of a separate little side proof to say that those two are parallel because this angle and this angle add up to 180 degrees, which means they're interior angles of a triangle, blah, 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 blah. There's a whole bunch of little stuff that we'd have to do to prove those. So it would probably be easier just to use the right angles, which are marked given, and these two angles, which are opposite angles, and then say that the third one is equal because it's just the third angle in the triangle. And I told you before that that is always true. If you've got two that are equal, then the third one is automatically equal. So what are we given in this situation? Remember, that's the second thing we have to write down. We have to write down our givens. And the only thing we're given here is that angle B and angle D are both right angles. So angle B is equal to angle D because they're both 90 degrees. So now we're going to go proof. And it might seem like we're repeating ourselves here because now I have to write those angles down again. So in, whoops, that's, in triangle DEC and triangle BAC, whoops, BAC, dot, 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 we're going to list our equal angles. Now remember, I got to make sure that one side of the equal sign has one part of the has one triangle, and the other half of the equal sign has the other triangle. Don't mix and match them around. So in order to make sure that I do that, I'm going to write them down D, D, C, E. So D, C, E. Make sure I put the angle sign in front of them. Now angle D was the same as angle B. And the reason for that is in our given statement. So we can just write given beside that. And our angle C is equal to angle C because of the opposite angle theorem. And our angle E is equal to our angle A because of the angle sum of a triangle theorem. So therefore, triangle DEC is similar to triangle BAC because of the three angles being equal. So angle, angle, angle similarity. And now we have to set up ratios to solve for the W. So let's take a look. W is across from the dot. So in the other triangle across from the dot is 27. So there's my one ratio. And now I need numbers. So this doesn't have numbers on here or here, so it looks like I'm going to have to take the 45. Now remember, I put the W on top here, so the 45 has to go on top here. And 45 is across from the double mark. Across from double mark here is 15. Now once you have that, it's just a matter of cross multiplying. So W times 15 gives us 15W, and then 27 times 45. And then we just have to divide both sides by 15. And if we type that into the calculator, we get 81. And since this is a word problem, we should say, therefore, the river is 81 meters wide. Okay, now the last one here, we want to prove that these two triangles are similar first. So it says a flagpole casts a shadow 12.4 meters long at the same time that Mrs. Caldwell, who is 153 centimeters tall, measures her shadow to be 1.3 meters long. How tall is the flagpole? Be sure you prove them similar before you use their similarity. So again, we're going to label these. I'm going to call this ABC. And let's call this XYZ. Z. So required to prove, triangle ABC is similar to triangle, and in this one it's XYZ. XYZ. And we need some givens. There's two things given here. The first thing that's given is that angle B and angle Y are vertical. Angle B is equal to angle Y, which is equal to 90 degrees. And the other thing that is given is that this is at the same time of day. So that means that C and Z are the elevation to the sun, which means that they're the same thing. So angle C is equal to angle Z because that is the sun elevation. That's what causes the shadow, is the angle of elevation to the sun, and that down there is what it is. So now we're going to say proof in triangle ABC and triangle XYZ. Well, these are the two angles that we need. Angle B equals angle Y, and the reason for that is because it was given. And angle C equals angle Z. The reason for that is because it was given. We already dealt with that in the givens. And then the very last one, angle A, must also be equal to angle X because of the angle sum of a triangle theorem. So therefore, the two triangles, triangle ABC, is similar to triangle XYZ because angle, 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 similarity. Okay, so we got three proofs for you there. I'm just going to set this up. We got to put the numbers on here so that we can use the similar triangles to find what we want. So here we want to find out how tall the flagpole is. So I'm going to put an X here. We know that the flagpole casts a shadow 12.4 meters long. And if we look over here, it says that I am 153 centimeters tall. I'm going to put that in meters though, 1.53 meters. And my shadow is 1.3 meters long. So if we set up the ratios there, X is across from this double mark here, so it goes with the 1.53. The 12.4 is also from this triangle, so it has to go on top. And it is the bottom here across from this top angle, so it's 1.3 that goes with it. And now we just have to cross multiply. So 1.3 times x is 1.3x equals 1.53 times 12.4, and then divide both sides by 1.3. And when we divide both sides by 1.3, we get 14.6 approximately. And that's in meters. And we need a therefore statement. Therefore, the flagpole is 14.6 meters high. And that wraps up this video.